As we get started in Chapter 7, we're going to be looking closely at the parent-child relationship and the born technique that is used in Inventor. The first thing I want to just make sure, I'm going to go over the end product so we can take a look at where we're going with this. So I'm just going to review a few things to explain, what is that relationship and what are we trying to create when we're creating these parent relationships and the whole born relationship. So the parent relationship, I'm going to start with that, is just looking at like the first feature of the part. So in this application, the base was the very first part that we created, and anything that was created in connection with that base view is then the parent, is the child in relationship to the parent. So all of the, like the main body, the rectangle cut, the center drill, those are going to be children of the base. So we have the base here, and then we created the main body. So that parent-child relationship exists when you're using features off of the original part. So for example, if I were to change something on the base, the main body would also change in relationship because those two are connected. The book uses a great example of what happens when you create. I'm gonna suppress one of these features. This is something that's covered later on, but we'll come back to this. So suppressing a feature will allow us to look at some, turn off one of the features that was created. So toward the end of this chapter, when you create the circular cutout, you will be looking at the rectangular cutout. So the rectangle cutout was established off of the main body, and then the rectangular cutout happened, and then after you did the rectangle cutout, you're going to have this center drill. So the center drill is going to be created by selecting this surface right here. So the surface is part of the rectangle cutout. So that center drill is a child of the rectangle cutout. So when we change something with the rectangle cutout, or it will update with it. So one of the exercises to make this leg a little bit shorter, and as that happens, that hole then goes through the part a lot, even further. It stays on this surface. However, as we're looking at suppressing and turning things on and off, let's take a look at what happens when the relationship did not include the off of a particular surface. So I'm going to turn the circular feature back on, and now I'm going to try to turn off just the rectangular cutout. I just want to suppress the rectangle cutout, and when that happens, it's automatically turning off the center drill because of the relationship that exists between the center drill and the rectangle cut. That center drill was sketched off of the top of the rectangle, so therefore that automatically cuts off, and I have no control of turning that back on to get the hole to go through this design. So at the later part of the chapter, what we do is we redefine the point for the center drill. Instead of doing the center drill off of the rectangular cut, the center drills then move to the bottom, where that center drill will always be going through this part. So it's important to understand this as you're looking at your parts, especially when you get into modification. So I'm going to go ahead and turn this off, and I'm going to go ahead and get started. We're going to look at how to turn on the planes that we have here, looking at this and turning on the planes using the 3 axes that we have and the work point as our center point. We'll look at turning the part into wireframe, and being able to look at our sketches and maybe get to some of these points to create a sketch that we haven't been able to get to at this point. So as we get started on this part, Inventor gets us to make a few changes to our sketch plane settings, and we're going to go up under the Tools button and go to Application Options. The first thing is to look at the display, not the display, I'm sorry. We're going to go to Sketch, and then we're going to change this right here where it has the look at sketch plane on sketch creation and edit, and we're going to take that off of the, uncheck the in part environment. So I'm going to hit apply there, and then the other thing that we had to look at was under part, just making sure no new sketch is required for that. So I'm going to close this now and go ahead and get started with a standard IPT file. So the very first thing is we're going to right click on our planes that we have specified here. So I'm going to right click on each one of these and turn the visibility on. So by turning on that visibility, those planes are going to be always available anytime we are creating our sketch. So we are looking right at those parts, and, right at those planes, and we're ready to create our sketches. So the first thing we're going to do is create a slot on the the XZ plane. So that's the plane that is parallel with our top view. So I'm going to create right click on that plane and go to new sketch, and then go ahead and start my new sketch. So I don't know if you just noticed that when I just created, oops, let me make sure I do that right. When I create a new sketch, the sketch plane did not just automatically orient back to back to the isometric view, so it didn't turn around like it normally would. When we turned off the setting for look at sketch plane on sketch creation, and we turn that off, the sketch will now stay in the isometric view. So that's what we just did by going back into Tools, Application Options, and at the sketch here, this right here. If this were on, the sketch would reorient, and it would be like a 2D sketch plane instead of the 3D sketch plane. So that's something you can kind of play around, see if you like it. Just want to make sure that you know that that's available there for you to use. So back to our sketch. So what we're going to do now is sketch a slot. We're going to just use the center to center slot, and I'm just going to draw something out here. I'm just going to pick some points and go back and define that as I get the slot created. So just dragging the 2 points and then specifying a thickness, and then I'm going to follow that with 2 circles that are concentric. I'm just going to lay those out, kind of jot those down real quickly, and then I'm going to go back and apply the dimensions. So I'm going to apply the dimensions to this and apply all the dimensions back to my 0, 0 point. You should be able to see that there. I can do all of these dimensions in this mode, so I don't have to go out of this and go like click on the top view. We're now able to work in our 3D or isometric view plane as we're creating this. So on your own, I'm going to let you put the dimensions on here and then adjust those as needed on page 710. The next thing after I get my dimensions on, I'm going to follow up on making sure you understand some of these parameters and how this could affect your drawing. Okay, with the dimensions applied, what I want to do now is look at the parameters under for each one of these dimensions. So we're going to look at the FX parameters. As you are pointing to your dimensions, there are 2 ways to find out what your parameter is. If you click on the dimension itself when you're looking to apply it, you'll see, well, my box is a little small there. You should see your parameter listed on that dimension, the edit dimension right below that. So that dimension right there is D3. Also, when you're looking at your parameters box, you'll be able to see that the dimensions that are there should have a different value. So you can see I've got several different dimensions here. And I can change my dimensions from the parameters right here, so I don't have to like go out and click on each one. So I'm just going to model this for you. So that 0.438, that's the space between the 2 centers. I'm going to go ahead and make that 5 inches as given to us in our textbook. So that's 5. And now I'm going to have to zoom out a little bit. The outside radius for this piece right here, I am going to have to click on that one to find out what that radius is. So that may be let's look and see what happens to D1. If we change that one to 1, that's the inside circle. So we don't want that to be 0.1. We want that to be 0.5. So that is that circle there. Then this one is probably all right. That's the second one. So that is this diameter. I don't want that to be 0.5. I want that to have a radius of 1. So I'm going to change that to 1, and that's going to update that one there. The D2 dimension, let's kind of back this out. So I have that may be the dimension that's right there in between the horizontal line and the origin. So I made that 0. D3 is that one, so we've got that one, and then this is the distance between the center point and the 0, 0. So I'm going to make that 0 as well. So the only problem we have here now is I don't have a dimension on this one. So I'm going to go ahead and hit done, and I'm going to apply a dimension for that one as well. So I'm going to click on dimension, and I'm going to pick this dimension right here. So I'm going to pick this circle. If I can zoom in on that right there. What in the world? Alright, so let's get that dimension there. So instead of assigning a value for this, back over underneath my parameters, what I want to do this time is I want to make sure that those two holes stay the same all the time without me having to go and put the dimensions on there. So if the first one was D0, that was 0.5. I'm going to put D0 for this one as well, and then that will have the same value as DO. So each time this dimension changes, that's going to change with it. Now, this may not make a difference in this problem right here where you only have 2 holes, but if you had a whole bunch of holes, you know, let's just say 20, you would want to make sure that you have some connection there. So if one diameter changes, they all change. This is a great way to establish that similarity between the holes and the sizes. So I'm going to finish this up. I'm going to hit done, and I'm going to go ahead and extrude this and finish this part. As done in the past, we can name this part. So I'm going to go ahead and name this base so I can keep track of the part that I'm working on. So the next thing we're going to do is look at making a few modifications. I'm going to change the view and the orientation, or the view for this to wireframe, so I can see some of the edges. The next sketch I'm going to create it down on this plane. And as I look at this, I just realized that I need to get this plane right here in the center of this part. So I'm going to have to go back to my original sketch and make a dimension change. So I want a dimension from the center of the hole to this center point here. I want that to be a 0, and I think what I do is I did the other dimension. So I'm going to have to erase this dimension right here, and I want to make that one 0. So then that way I've got my part, the center of the part, on the center of the work plane. So I'm going to hit finish sketch and then take a look at that there. So that's exactly what I wanted. So when I create my next sketch, I'm going to create my sketch on this work plane right here, and I'm going to be sketching right there on that origin. That is going to be my center point for my arc. So I'm going to go to arc, pick the center point, and I want to pick down on that bottom surface. So I'm going to pull along that edge. It is going to be 180 degrees. So I'm going to type in 180, and then I'm going to draw a line from one end point to the other, and then I'm going to put a dimension on this arc, which is 1.75, and that's going to set that up. So the next thing I'm going to do is finish this sketch, and I'm going to use the, when I extrude this part, I'm going to use the symmetry. So then that way this part is symmetrical, 2.5 inches from each side. And there we go. I'll continue on the next video.